All right, Science 10, let's look at these 4 formation reactions and see how to finish them off and to also balance them. Your main task is to, of course, make sure you've got your periodic table in front of you. It is not possible to do this kind of chemistry without the periodic table. So what I've done is, you want to focus on the 2 elements that we're looking at here, calcium and nitrogen, and we're going to put them together. Well, ultimately, when we're combining a metal and a non-metal, we need to make sure that the charges are balanced. So calcium wants to give 2 electrons, or is positive 2, and nitrogen wants to take 3, so those don't quite balance off. So we'll look for a common multiple between 2 and 3, and that's going to be 6. So therefore, we're going to need 2 calciums, and no, not 2, come on, 6. We're going to need 3 calciums and 2 nitrogens. So it's going to be a 3:2 ratio. And so let's put that together. Ca 3 N2, all molecular, all ionic compounds are solids. So this is going to form a solid. That's the beauty of ionic compounds. Now we need to balance this. Looks like the calcium is out of whack. Nitrogen's on side, so I believe we'll just put a 3 here. We're gonna have 3 calciums, 2 nitrogens, 2 nitrogens, so just put a 1 there and put a 1 there. Read this out loud. 3 moles of calcium are added to 1 mole of nitrogen gas to give us 1 mole of calcium nitride. So always also name them, even if it's just in your head. Let's move on, use the same process again where we look on the periodic table, we find aluminum, we find oxygen because we're going to combine them. Again, it's a metal and a non-metal, and make sure you're clear on how I'm figuring that out. When we look on the periodic table, everything to the left of the staircase is a metal, everything to the right of the staircase is a non-metal, and we can always combine the atoms that have a charge, a positive charge, with the atoms that have a negative charge, no question. Okay, let's pop back here. So we've got 3 aluminums, 2 oxygens. Again, we look for the lowest common multiple to get this in its simplest ratio. So if we had 2 aluminums, that would be 6, and if we had 3 oxygens, that would also make 6. So 2 aluminums to 3 oxygens. So this ratio is a 2:3 ratio. Again, if you think about it, 2 aluminums, it's going to be positive 6. 3 oxygens, that'll be negative 6. The molecule that forms has to be neutral, and ultimately there have to be enough oxygens available to take the aluminum's electrons. And 1 oxygen can only take 2. So therefore, you need more than 1 oxygen, and even if we had two oxygens, that's only going to take 4, so we need up to the 3 oxygens to take those electrons. All right, let's write that formula. Al2O3. It's also a solid because it's an ionic compound. Looks like it could put a 2 here, but look at this oxygen. Again, 2 and 3, that looks like to be a better place to start this balancing act. And ultimately, we need a common multiple again of 2 and 3 is 6. So in other words, we're going to have to go with 2 here. So 2 times 3, that'll be 6 oxygens. And I'll put a 3 there. Okay, the oxygen is balanced, but the aluminum is not. 2 times 2, there's 4 aluminums on this side, so let's put a 4 right there. Continuing on, potassium. Well, right there is potassium. We know that all metals are just simply monatomic. Put a line here. K. Oops. Oh, where we're doing it. We're doing it down here. K solid. Put the line there. Plus iodine. Iodine is, check it out, group 17. You need to know that all of these are diatomic. F2, Cl2, Br2, I2, At2. Okay, so iodine is I2 and it's a solid because it's clear here, right? Again, the periodic table is telling us all of this. Put the line right there because we're going to need to balance that. Little arrow, these two are going to combine. For sure they're going to combine. This one is a metal, and this one is on the other side of the staircase. It's a non-metal, so for sure they combine. Oh, and a nice 1-to-1 ratio. Ki, solid. Still looks out of whack though. There's 2 iodines there, only 1 there, so let's put a 2 on this coefficient here. And we better put a 2 over here now because the potassium is not balanced. And we'll put a 1. 2 moles potassium plus 1 mole of iodine is going to give 2 moles of potassium iodide. Okay, magnesium. Again, magnesium is a metal. So Mg, S, put the line there because we're possibly going to need to balance this. Plus phosphorus. A reminder, phosphorus is P4, sulfur is S8, oxygen O2, nitrogen O2. All of these are diatomic. Hydrogen is H2. So you need to have that written on your periodic table, and you need to start to be comfortable just knowing that stuff as well, but definitely write it on your periodic table. The phosphorus exists as P4, solid. Again, it's nice and clear. These two are ionic. Magnesium is a metal, phosphorus is a non-metal, so definitely they're gonna combine. We need a common multiple between 2 and 3. That's going to be 6. So we're going to need 3 magnesiums, and we're going to need 2 phosphorus. So it's going to be Mg3, P2. It will form a solid. It's ionic. It's looking a little out of whack. Well, let's start with the phosphorus. If I put a 2 here, I'm going to have 4 phosphorus, but now 6 magnesium, so I just put a 6 here. 6 moles of magnesium plus 1 mole of phosphorus will give us 2 moles of magnesium phosphide. Key thing, this is the cooking part of chemistry. This makes sure that we get the exact proportions. These coefficients can never be a fraction, and they always need to be in their simplest form. So, you know, we look at 6, 1, 2 here and make sure that it can't be simplified. Can't go down any further. We got a 1 here. 2, 1, 2. Yep, that can't be simplified any further. 4, 3, 2. Same thing, can't be simplified any further. 3, 1, 1. Definitely can't be simplified any further. Okay. Try some of these on your own, and try these same 4 on your own without me, and just see if you can get the process down. Take care.